This video is going to be the final video for topic 12, and in this video what we're going to do is look at a transform function g of x, identify the toolbox function that it was built from, identify the transformations that were used to create g of x, and then come up with a formula or equation for g of x. So in this example, g of x looks like it is built from a square root function, so we want to identify that our function family or toolbox function is the square root function. And then we want to walk through the sequence of transformations we looked at in the previous video and identify what transformations were applied to the square root function, the square root of x, in order to build g of x. And we'll do that by keeping track of key points on the toolbox function and identifying how we had to transform or move them to create g of x. So first look to see if any horizontal shifts have happened. So horizontal shifts, and if we look at this key point here, it should correspond to this key point here. It looks like we've been shifted over 4 units, which would also take this point and shift it over 4 units. So it looks like we have a shift of 4 units to the left. Then identify whether there's been any reflections. It doesn't look like there has been an a y-axis reflection, but it does look like there's been a x-axis reflection, because here our graph's kind of opening downward, going up. Here it's going down, opening upward. So it looks like we've reflected over the x-axis. So to get something that looks like this, so it looks like an x-axis reflection. And then look and see if you can identify whether there's any stretches or compressions. And in this case, I'm going to say it looks like there's been a stretch of 2, because usually you start here, you go up 1, over 1 to get to the next lattice point. Here we're going 2 units and then over 1 unit to get to the next lattice point. That looks like a stretch of 2. And we'll look at another way of figuring out stretch here in a little bit. And then 4 vertical shifts. Yep, it looks like this has been moved up 5 units. So up 5. And then once you've identified the transformations, you build your function g of x. G of x looks like he's the function that's built from the square root function by shifting 4 units to the left. So to shift 4 units to the left, it's going to be x plus 4. We add 4 to the input variable. To get the x-axis reflection, we need to put a negation in front of the square root. To get a stretch by a factor of 2, we need a times 2 multiplier. And then we need plus 5 to move g of x up 5 units. Sometimes people are a little bit nervous with finding the stretch, so there's another way you can get at stretch if you're uncomfortable with trying to figure it out by looking at lattice points. And sometimes you don't have a lattice point, so here's another way to deal with this. So you take your function g of x that you're building, and let's say you're uncertain if there's a stretch or compression, so we'll put a question mark here. In fact, we'll say we're stretching by a factor of a, kind of corresponding to the a that's being multiplied by the f of x up here. So we could build our function. We could say, hey, it's going to be minus a, there's my reflection in the x-axis, minus a times the square root. Here's my x plus 4 to get my shift of 4 units to the left, plus 5, there's my vertical transformation or translation of 5 units. And then just grab a lattice point on your function, or any ordered pair on your function. It doesn't even need to be a lattice point. Any known ordered pair. So here, for example, we have a -3 as the input, +3 on the output, and plug this information into the function g of x. Right? This says the output is 3. G of x represents the output, so 3 equals -a times the square root of x. X is just -3, so -3 plus 4 plus 5. And this equals, now simplify, 3 equals the opposite of a times the square root of 1. Negative 3 plus 4 is 1, plus 5. Subtract 5 from both sides, we'll get negative 2. Equals negative a. Square root of 1 is 1. Get a by itself. I'm sitting here with a negative 2 equals the opposite of a times 1. Just multiply both sides by negative 1. That'll give us 2 is equal to a. And now you know what your stretch is. So you replace a with the 2. So again, play the same game. Identify what is the toolbox function. In this case, it looks like it's the squaring function. So it looks like we started with f of x equals x squared and built a new function, g of x. So what does x squared look like? Well, he's a parabola, passes through those two nice lattice points. So here's my squaring function. Lattice points at 1, 1, 0, 0. And identify what's been done to f of x to create g of x. And clearly it looks like there's a shift of 2 units to the right. So horizontal shifts. 2 units to the right. Any reflections? Yes, it looks like a reflection in the x-axis. X-axis reflection. Because if we move everything over 2 units to the right, the parabola is still going to be opening up. To get it opening downwards, we need to reflect it down. And then does it look like there's any stretches? And I'm going to say no stretches. And I'm saying that because usually you go over 1, up 1 to get to the next lattice point. Here you go over 1, down 1. That ratio's the same. It's a kind of a 1-to-1 ratio. And again, we could, if we are uncertain, we can always just say, gee, I'm uncertain. Maybe the stretch is a. And then 4 vertical shifts, none. And now we can come up with our equation. I can say, hey, I have a new equation, g of x, that was built from the square root function. If you're uncertain about the stretch, just represent it with an a. The negative for the x-axis reflection times the squaring function. To get it to move 2 units to the right, we have to subtract 2 from the input variable. And it's the squaring function. And then we could solve for a by grabbing any lattice point we want that's on the final function. So this is a 3 and negative 1. Put that information in. So g of x represents the outputs. Replace g of x with negative 1. This will equal negative a times, replace x with 3 and put the 3 minus 2, and this is squared. We get negative 1 equals a times the opposite, there's a negative there, opposite of a times 1 squared, which is just negative 1 equals the opposite of a. Multiply both sides by a, we get that the stretch is 1. And then we replace that into the final equation, so we get that our g of x is just negative x minus 2 quantity squared. Again, we could have identified that this was going to be a 1 by looking at the fact that we're moving over 1, up 1, and the final result, there's still this 1-to-1 type motion to get to the lattice point. So here's my function g of x. And I actually used GeoGebra to draw in the toolbox function. The toolbox function, this is a cubing function. So g of x has been built from the cubing function. And again, we need to identify how has it been built. So 1, look for horizontal shifts. And it looks like this point has been shifted over 1 unit to the right. That's horrible. I can't leave it like that. To the right, not much better. 2, look for reflections, and in this case it looks like we have been reflected over the x-axis. So a shape that started like this now is doing this reflection in the x-axis. Could argue that it's a y-axis reflection. We're going to go with an x-axis. And then do we have any stretches or compressions? Well, on the standard function you go over 1, up 1. It looks like here it's an over 1, up 2 kind of thing to get to the next point. So to me this looks like a stretch by a factor of 2. Again, if we were uncertain, we could just put A here and use an ordered pair to figure A out. And then 4, do we have any vertical shifts? And the answer is yes. It looks like we moved the origin over 1 and then up 2, so it looks like a vertical shift of up 2 units, and then we can build our final function. G of x equals, what happened to the cubing function? It moved 1 unit to the right, so we have to subtract 1 from the input variable and cube it. An x-axis reflection needs a negative sign on the outside. A stretch of 2 needs a times 2 multiplier, and a shift up 2 needs to add 2 to the function. And this is the final example. So here we look at this, and it looks like the parent function or toolbox function is the square root function. It's got a couple nice points on him. So our toolbox function is the square root function in this example. And it looks like we have a shift, if I'm looking at this, a shift of 1 to the left. We have to be careful sometimes. 1 to the left. And then for reflections, it looks like there's been a y-axis reflection. And when we have a y-axis reflection and a horizontal shift, we need to be really careful with these. 3, there's usually you move over 1, up 1. Here's a move over 1, up 1, so it doesn't look like there's any stretch. And the square root function started on the x-axis. It looks like it's still starting on the x-axis, so it looks like there's no vertical translation. And so to get the function, I'll get g of x equals, it looked like it was the square root function, shifted 1 to the left, so that's plus 1. And now I have to be careful. If I'm going to do my y-axis reflection, I want to negate the input, negate the inputs, which is going to look like negative x minus 1. And so this looks like a shift of the graph 1 unit to the right, and then reflected over the y-axis. Shift it 1 to the right, then reflect it over the y-axis to get that final result. So notice I had to put the left one, the 1 to the left translation being added, the 1 being added to the x, I had to put it in parentheses before I put the y-axis reflection in place. In all of these, so my final comment would be, in all of these, the best way to do this is build g of x. Build what you think is g of x. And then simply take GeoGebra or your graphing calculator, graph this equation. Here's your check on work. Graph this equation and see if it matches the picture that you have in your homework. If the pictures don't match, if when you graph your equation it doesn't look like the equation that you were trying to build, then you know that you've made a mistake and you need to identify where the mistake happened. And then, as always, contact me if you need help.